Next on our quest to learn all of the different ways you can ingest logs into Loki, we have FluentD and Fluent Bit. Are they really indistinguishable like Tweedledee and Tweedledum? When would you use one over the other when writing logs into Loki? Let's find out. FluentD and Fluent Bit are both open source data collectors hosted by CNCF. Like other collectors, their role is to unify the collection, processing, and distribution of telemetry data. Both were originally designed for handling logs, though they have evolved to act as more generalized telemetry collectors, like Grafana Alloy and the OTel collector. Since we are talking about Loki, we are primarily focused on how they both handle logs. So why are there two collectors? The answer is down to footprint and performance. FluentD grew to become a complex collector with more than 1,000 external plugins and provided reasonable performance. Fluent Bit, on the other hand, was designed with a much more minimal footprint in mind, so it could be deployed on embedded Linux devices. It has way fewer plugins than FluentD, but this is built by design. Although both are still relevant, many see Fluent Bit as the successor to FluentD due to the performance gains. One of the core concepts of both collectors is to structure telemetry data within a JSON format, as much as possible. The reason behind this is to provide a structured format that unifies all other pipeline stages. A pipeline is built using plugins, which fall into 6 categories: input, parser, filter, buffer, routing, and output. Now, we aren't going to do a full deep dive into FluentD and Fluent Bit. There are plenty of great videos and content online that will get you through the foundational concepts. In this tutorial, we're going to learn how to configure and deploy the Loki community plugins for both FluentD and Fluent Bit. Okay, before we continue, there is a quick disclaimer. Both plugins are community supported and open source. They are subject to change at the pace that the maintainers wish for them to. So certain features from Loki, such as structured metadata, might not be included yet. Since these are community plugins, they do have to be installed as third-party plugins in both collectors. Our recommendation is to use the pre-built containers we host via our Docker repository, which contains the most up-to-date plugins based on the repo's main branch. However, there are other methods of installation. Fluent Bit has a Helm, so you can use that with your Kubernetes installations, and within FluentD, you can also install the Loki plugin using the Fluent Gem method. With that out of the way, let's jump into the tutorial on Killer Coder and start configuring both agents. To start, we'll clone our repository and spin up our observability stack. Now, in your solution, you may be using one of the Fluent agents or even a combination of both. But in this tutorial, I'm purely setting up both to show you the difference in configuration. We're going to start with FluentD. Plugins are defined and configured within a configuration file. To start, we'll add a source called forward. This essentially creates a listening endpoint which accepts the forward protocol, which is used by FluentD, Fluent Bit, and its clients to route messages between one another. Let's take a quick look at our demo architecture to understand how we are using this plugin. The carnivorous greenhouse is made up of 6 Python services. Each service has a custom logging class which is implemented based upon the logging style I would like to show in the demo. In this case, we're using the Fluent Python client. It acts a lot like the OTel Python client in terms of setup and lets you use the inbuilt Python logging interface, so your code and how you log within your application does not need to change. Now, that being said, Fluent does have its own metadata called tags. These are primarily used for routing within the agent. This is useful when a particular log needs to go through a specific transformation when others don't. In my case, I have defined the following tag structure for each: service.service name. We don't do any creative routing in this demo, but you will see it defined within our configuration, so it's worth pointing out. Okay, back to the configuration. I have already added this input plugin to your config, just so we can stand up an initial configuration of the collector, but you can find the configuration file here. Next, let's move on to our main event, the Loki output plugin. You can see we begin with our tag routing we discussed earlier. Essentially, we are telling FluentD to route all records with the parent tag service through this plugin. All child tags are wildcarded, meaning we'll accept any child of service. We then define our type. This is our pre-installed Loki plugin. Next, we'll define a static Loki label so we can distinguish between the logs coming from FluentD and from Fluent Bit. And now onto our dynamic labels. This does require one final look back at our architecture diagram. Within our login class, we do define a slightly custom format, which includes two key value pairs you don't get by default when using the Fluent clients: service and instance ID. The one we really care about is service, as we will use this within Grafana's new log explorer to distinguish between our different services. Back to the configuration. Within our labels attribute, we can use record accessor syntax to extract labels we want. In our case, these attributes are at the top level, so we just specify $, then the key, such as service, to extract the tag value. At this point, we can also rename our labels, so I've changed service to service name and left instance ID the same. Lastly, within our configuration, we can define the buffer. This helps with rate limiting and how quickly you want logs flushed from the pipeline. Let's copy these changes to our configuration file. Once saved, we actually need to restart our FluentD container for these changes to be picked up. Before we configure Fluent Bit, let's skip ahead and deploy our carnivorous greenhouse application. Start by generating some logs, including some errors, and then we can look at the results within Grafana so we can see how our logs have been ingested. As you can see, within our log explorer, we have 6 services. And if we drill into the logs of our main app service and look at the log attributes, we can find our agent, service name, and instance ID labels. Now, let's jump back and configure Fluent Bit. The first thing you'll notice is the format of the config file is quite different to FluentD. We still define plugins, but this time we define the category of plugin and then the type becomes the name of plugin. Let's take a look at how to set up the forward plugin as an example. Start by defining the category, in this case which is input, and then the type forward within the name rather than the type. The rest of the configuration attributes are similar to FluentD. Moving on to our main event then, the Loki output plugin. In Fluent Bit, there are 2 plugins, the official Loki plugin of Fluent Bit, and then the community designed plugin called Grafana Loki. In this case, we actually recommend using the community plugin since it has a few more features which improve the flexibility of Loki label definitions. Again, we define the category first, which is output, and the name of the plugin as Grafana-Loki rather than just Loki. Then we define our match. If you watch the FluentD section of the video, then this is how we route tags. Once again, we want all records within the parent tag service, and we will accept any children under that parent. Last but not least, we define label map path. This is how we define our dynamic labels in Fluent Bit. We include a JSON file which tells our Loki plugin how to handle particular attributes of our log record. In this case, we are mapping the service attribute value to service name, and instance ID remains a one-to-one mapping. Like FluentD, the Fluent Bit container requires a restart to accept the configuration changes. Let's create one final plant in our app and check Grafana once again. We can now see the label value Fluent Bit underneath our agent within the Explorer. Based on the way we have set up this demo, the log entry should be equivalent to FluentD, though the format might vary. And there you have it, 2 more agents ticked off the long list of ingest methods for Loki. I'm not going to lie to you, choosing a collector can feel like a daunting task, as there is plenty of options out there, each with bonuses and kinks. I hope these videos give you the beginning steps to choose which is right for you. The best part is Loki is flexible enough to allow you to swap and change ingest methods as your solution evolves, so don't feel locked down to one solution. Next up, we're looking at the Loki plugin for Log Stash. We are also still cooking up our deployment-based videos. Until next time, my name is Jay Clifford. Stay curious.